Hello, everyone. Great to see all of you here. My name is Avinash. I'm co-founder CTO at Nexla. Today, we are going to talk about how data fabric architecture, how data products can be building blocks for data integration. Nexla is a data engineering automation company. We're built on a data fabric architecture. And in today's session, we're going to take a look at first principle look at data integration, how data integration has been done so far, the challenges with it, and then propose a way to do data integration better via data product design. What I'm going to do in the next few minutes is go through a bunch of slides, set the context on how data integration has been done so far, and then very quickly um, move to a demo and then some Q&A later on. So let's get started. All of you know this, right? Data engineering, in my mind, is a function that makes data ready to use. But data ready to use means different things for different people. For an analyst, it might be running Tableau on top of Snowflake. For a data scientist, it might be loading a huge data set in Jupyter Notebook and try to do some AI ML on it. For a business user, it might be trying to do some operational metrics in a spreadsheet. For a developer, it might be needing data and an API. But at highest levels, if you think about data integration, you need to do three things. You need to be able to connect to different systems, just integrate. You need to be able to translate the data format stuff between multiple different systems, which is preparation. And once you have built a data flow which is doing integration and preparation, you want to be able to monitor this so that you don't get woken up in the middle of the night or 15 days later after something has gone wrong. So you need to be able to monitor it. So that's, in my mind, what data engineering is all about, what data integration is all about. How is this thing done today? We have seen this in different places. Data integration is fragmented and chaotic in most cases. And a lot of it is legacy software of how these things are built. You might, in a pretty big enterprise, you would see same sources and targets being connected by different set of tools using different design patterns. The developer who coded it is no longer with the company, had this code running on his local machine, and you are on an unsupported version of a tool. These solutions do get dated very fast, and you end up in this chaos of, even if I have to move data from, let's say, a FTP server to a database, you might have 7 different ways to do this, so you end up with that chaos on the left. Now, this problem got us slightly better in the last few years, where with the advent of modern integration platforms, we have had standard way of doing things. But this has given rise to another problem, which is the problem of fragmentation. What does fragmentation get us? Um, you have a particular tool that gets you from a SaaS service to a data warehouse. You have a different tool that gets you from a data warehouse to a SaaS tool. You have a third tool which will get you from a file system to a database. You have a fourth tool which will get you to a streaming system. These things go on, but the meta point being, based on the direction of data flow, you have to choose a slightly different tool to work with, which ends up being a challenge because you don't want to work with a tool. You want to have some sort of unification within your data stack. Now, in the next slide, I'm going to propose a way that this unification can be achieved using the concept of a data product. And to introduce that, I go to my software engineering roots of a very important design paradigm in software engineering, which is called as abstraction. Um, think about data product as an abstraction layer between your source and a destination. So your source connector or your source system, if I can build something on my integration layer, which can no matter connect to anything, give me a product, give me a data product. And on my consumption layer, if I can build something which then take this data product and be able to push that out to any data system out there, I would have, to a great extent, solved the problem of both chaos and fragmentation. Now, along with this, if I can abstract the way this data product gets executed. So, for example, if I have this huge data product which is doing billions of records being joined with each other, if I can execute that data product in Spark, or if I have a streaming data product, if I can execute that within Kafka, I would have, in some ways, been able to achieve uh, a design paradigm where I can, independent of data flows, direction can build any data integration, and then I can build that data integration at any speed. I can run that at any speed as I want. So this is sort of fundamental of how we think about data products, and collection of these data products along with ability to run at any speed forms the basis of a data fabric architecture that has become a buzzwords in the last few months. So now I'm going to introduce how do we typically do this? How do we bring order to this chaos and fragmentation? And the answer lies in automation. If you can automate certain common tasks in data integration, build around data products, and provide access mechanisms to those data products, a lot of things that a data engineer typically does from an integration perspective can be done really, really quickly, can be less more frustrating and much more streamlined. So how do we do this? So we said connector is a game that you can potentially never catch up. There'll be always be more systems that you want to connect to as opposed to the number of connectors that you have. So what we did is we built a technology which allows us to generate connectors instead of having to hand code them. Now, what that does is you throw a new system at us, you don't need to write a new connector. We are able to generate connectors on the fly, and we can do this bi-directionally. So I can generate a connector for you, which can read data, which can write data to any system out there very easily. Then we tied these connectors to this concept of a data product. The connectors gives you IO, but how do you make it easy for a user to understand it? How do you build a common interface on which you can build any feature on your product? So we introduced this concept of auto-generated data products. These are logical data units. There is no physical data being stored against them. Think about our automated data products as containers. What containers have done for compute, automated data products are trying to do this for data. And the third element is this automation then needs to be combined with human collaboration. How does a human access this? So if I go back to my first slide, data is ready to use. How do different people access this ready to use data? That can be done via no code for data users and platform for data engineers. So APIs and CLIs for data engineers, but no code for data users. So you can pretty much, if we can build a paradigm like this, where you can generate connectors to get you data products, and operations on data products can be done using low code, no code tools or an APIs, you will have a system which will solve most of the shortcomings of a data integration challenge. And under the hood, we are now able to run this in any environment, whether it's SaaS, hybrid, or multi-cloud. And we are able to run this at multi-speed. So we are able to run this at batch, streaming, or real time. Same interface, same data product. If it has been streamed out, it is being run in a streaming engine. If it's a batch operation, it's being run in a batch. So we're able to unify all of these things into an all-in-one platform, which is able to do uh, data integration built on data fabric architecture and is able to push irrespective of the flow of the data direction, you are able to use that particular platform. The next slide, I'm going to zoom in on these data products and talk about how these data products become those building blocks. But again, the engineer in me wants to get to the first principles. And the first principle that I always want to, before I define a data product, let's define what is a product. And the analogy that I always give about what is a product, think about product as it's a finished object, right? It's a finished thing. Think of shoes as a product. The raw material for shoes ends up being a fabric or a leather, but a finished product is what you would typically use to run. The finished product has certain criteria capabilities. You can go search and discover this particular shoe in any marketplace out there. So a finished product is something which has a very standard user interface. You can discover that particular finished product. It's made up of one or more multiple raw products, and then it has a very, very well defined use for the consumer of that particular product. Now, knowing this in real world, which is a shoe, I'm going to introduce this concept of a data product. What's a data product? So a data product, what's raw material for data product? Rows and columns of data are raw material for a data product. There might be some business rules. What is the finished product? It's a product that can be consumed. It's a product that somebody can relate to, can build an algorithm on it, can build an operational dashboard on it, and stuff like that. This particular product will have some sort of rules of engagement, will have some data contract associated with, and then it can be consumed in multiple different ways. So think about this as you can derive this data product, you can derive this data from in multiple different ways from raw data products, which is very similar to shoes. You might have fabric and leather, but you can produce multiple different types of shoes with that particular product. Now, if you zoom on to the image on the right, the data product has various characteristics. It has a schema associated with it. It has some data characteristics associated with it. The key thing being, no matter where you're fetching this data from, the data product looks and feels exactly the same. It has access control rules. It has ways to manage errors. It has ways to register an external catalog system and being interoperable. But at a very, very fundamental level, no matter where your data lives, this data product feels and looks exactly the same. And that's what we're going to talk about on the next slide, where so how do you generate data products, right? Now, all of us have multiple different data systems within our organization. To generate these data products, you need this concept of a metadata intelligence, and that's a layer that we have built in our product, which allows us, no matter where your data lives, to be able to connect to it, do a quick check on how those data products look like, and be able to generate this via introspection. No matter what your source of data is, we are able to, it can be a Parquet file on S3, it can be a Delta table, it can be a Kafka topic, it can be a Salesforce opportunity object, a Workday employee object. Within Nexla, this data product looks and feels exactly the same. So for a user, they don't need to learn how to connect to a particular system. All they really need to know is, this is how the data product appears, and this is how we can work with this particular data product. So now that we have a base data product, how do we derive data products out of these base data products? And that's my next slide. Now, this base data product might have some PII information. You might want to hide this. You might want to enrich this base data product with a few other data products to create a more meaningful consumable data product. Now, think about this. This is your shoe. The shoe here is consumed by multiple other things, or is a but it's manufactured by joining multiple things together, and that's why, and those are the operations that you'll typically do in your data product. You'll transform, you'll enrich, you'll combine. And once you have a product that you think is consumable, you can do a bunch of different things here. At scale, you'd have multiple different data products. It will be a data product library, but stuff that you can do. Most common integration, you'll be able to, because this data product is polyglot in nature, you can push that data product into any system of your choice, be it a warehouse, be it a message bus, be it a data lake. You are able to do all of that stuff. Along with this, you can do a data product marketplace where you can buy or request more data products and build a workflow around that. You're able to do discovery with search. You're able to share these data products and create a sort of data exchange. So having this fundamental data product consumable entity exposes you to a lot of different options that you can do here. My next slide talks about a typical workflow of a user within Nexla. How do they come there, generate data products, create new data products, and how are they consumed by a typical data integration use case? On the left-hand side, we have about 300 odd systems that are predefined to build predefined connectors. But as I said, we can generate connectors for any system on the fly. So the possibilities that you can connect with Nexla are infinite. These systems are tied to our metadata intelligence layer. This layer knows how to generate data products automatically. So the moment you point this to a file system, it's able to interpret what are different types of schemas in that file system. You point it to a database, it can tell you what are different tables and try to generate a schema out of all of this. If you point it to an API, it can do all the exact same thing. But given credentials, we can scan through data, looking at various characteristics, and produce these data products that we call as net sets. Once you have this auto-generated net set, you can do no-code, low-code transformations to combine, to filter, to transform and create a ready-to-use net set. This ready-to-use net set is your shoe. You are able to take this net set and you're able to push this out into various systems. Various systems that you can push this out to. So this is where your polyglot consumption comes into play. You can ETL this to a data warehouse. You can ELT this. You can run this in Snowflake, and this can be your ELT data product. You can run this in Snowflake and push this out to a Salesforce. That's your reverse ETL flow. You can stream this out to Kafka. You can build API integrations on top of these data products, which can be an API gateway interface. So it's the same data product, same polyglot abstraction, but based on your consumption, you can choose a different design pattern. So if you remember my first slide, which was about fragmentation, this is how we solve fragmentation and the chaos by providing a very, very easy way to consistently do these data products. Under the hood, all of this is run in modern execution engines. The user probably doesn't even know where this is actually being run. You are able to run this as a batch process within Spark. You are able to run this within Kafka. You can run this within Snowflake or any other engine that is well suited for that particular architecture. So, very high level, what this slide shows is ability to consume these data products in multiple different ways, response basis of data integration, and that is what enables you uh, to to reduce the fragmentation and chaos that you typically have in the data integration world. The next slide, I'm going to take data product centric approach and redefine certain integration operations that we have been doing uh, for for as long as I can remember. Now, think about this. Creation of data products is like extraction. I connect my system uh, to S3 and I automatically generate data products. That's like extract. Creating those combining those data products and creating ready to use data products is like transformations. You're transforming data products. Pushing these data products into any system of your choice is load. So the terminology that we have known for so long, I'm just trying to apply that on the data product ecosystem. Ability to search is catalogs, right? You're able to catalog these data products, your ability to search those data products, ability to manage errors, which includes data quality, put validations. You're defining your data contract, and your data contract on those data products ends up becoming validation rules. Ability to govern. So you have this option to attach ACL list with a data product, and that becomes your governance layer. Ability to put this data product out in a marketplace. You're able to build a data product marketplace, as it were. Ability to share this. So a data exchange type of a concept. You can share this data product with somebody else and you can build a data exchange here. Ability to log what is going on in the journey of this data product, and that gives you a lineage layer. Ability to have these data products which are logical. This is your multi-cloud data layer. So stuff like this allows you, and this is where I summarize all of this, how different well-known operations in the data product landscape can be actually uh, traced back to an operation that all of us really know well about, which is extract, transform, load, lineage, uh, contracts, quality, etc. Very quickly, I'll just quickly talk about what are the different customers that use Nexla, and then I'll quickly go to demo. As you can see, customers across the space, across retail, across financial services, across healthcare are using Nexla. We are ISO SOC 2 certified, even HIPAA compliant. We are the highest rated integration tool on Gartner at about a 4.9. We are cool vendor for integration, and we do have a lot of mentions around active metadata management and event stream processing. At this point, I'm going to quickly switch to my demo screen and then quickly show a quick demo of the product. And I'll definitely leave some time to ask any questions as well. Quickly go and so this is what a data product looks like. This is what our dashboard looks like. You come in the dashboard, you see different uh, data products that are in there, any errors, notifications that are out there. This is our next set tab. One of the key things that I was talking about was how no matter where the data is living, it shows up more or less the same. So in a Postgres, in an Oracle dashboard, in an Oracle database, in Salesforce, in some API, FTP server, these look and feel exactly the same. And what does that look and feel look like? This is a blown up view of how a particular net set looks like. This net set has some description, some schema. The schema is automatically detected moment you point us to a data source. It automatically interprets what are the type of fields that are in there. So it interprets, oh, this thing looks like an email. This thing looks like a credit card. This thing looks like a phone number. It has statistics on how often the data has been processed. It has notifications about any notifications that were generated. It has activity trail about who changed what, and complete audit log of what has been happening through the life cycle of this particular data product. It has error data to show you any errors that might have happened. And then you can also share this. You can share this net set with somebody else. So think about this. When you point us to an S3, we are able to automatically generate these data products. That process of pointing us to an S3 looks very similar to, say, create new flow, and there are about 300 systems, but you can combine, you can generate your own connectors on the fly in the product as well. I'll quickly show you an Amazon S3 example where you can just take an existing credential, point this. I'm just going to a quick example here. You can select your folder, you can decide how often do you want to run this, and this thing would go and automatically interpret data products on the fly. So we, at this point, I'm connecting to S3, my metadata intelligence layer is running behind the scenes, and it is trying to detect a data product, and very went in and detected this data product, which looked very similar. You can register this on a data catalog, and then interoperate with bunch of tooling on in the ecosystem, whether it is catalogs, whether it is DBT, whether it is um, Slack, notification tools like PagerDuty, etc. At this point, I can now decide how do I want to build a ready-to-use data product from this. So for this, I can come in here, I can click on transform. Now this view on the left-hand side is my input, on the right-hand side is my output, and I am now trying to construct what should be my ready-to-use data product. There's a recommendation engine built in here, which will automatically recommend what type of operations you can do on this. So when I select email, it tells me, oh, you can MD5 the email. So I can MD5 the email, and this is something that if I select my first name and last name, it tells me, hey, do you want to concatenate first name and last name? So you can do stuff like this very easily. Apart from that, this is your no-code way of doing data. If I want to join this net set, right? So I want to, let's say I want to join this with a company net set, and I want to do a lookup. I can do this join very easily on the attribute ID, and I'm going to choose my advertiser lookup. And on the right hand side, you would see that okay, I have this company, which so this one got translated to Google, two got translated to Facebook, etc. So you can join net sets. You can also go and do stuff like write your own code. So I have some code here which is going to mask data. So I'm going to say this is my masking function. I need to mask payment attribute. And say I want to mask my payment and I want to do this on the last four characters of payment. And let's say run net set. So on the right hand side, you're sort of creating a ready to use net set that you can decide to share with somebody, that you want to register in Colibra, and that you want to essentially push this to a destination system. Right? From here, click save, and close. So at this point, this is the net set that got created. It has the exact same properties. The schemas are automatically auto-interpreted. But the interesting thing here is share. So I can decide that I want to share this with my demo team. So share data. So now the demo team, when they log in, they'll have access. I can share with individuals, but they don't see how this is generated. They only see the output layer. So they would not never be able to see what was the source layer. They will only see how this thing was generated. At this point, I can continue this process as long as I want. But what I'm going to do very quickly is I'm going to, one thing that I'll probably also show you is how you can add validation rules here. So you can say, okay, I want to add validations. I want to say, in this particular thing, I always want the company to be required. So for some reason, if I was not able to do a proper inner join on the company, I want the rows to be filtered out. And whenever that company is not present, you would actually see that row gets filtered out before it gets pushed out. So you can define all of these validation rules as well. Now I have this layer. How do I consume this? Now I can consume this. How do I materialize this? Exactly same thing. It's inverse of what we did on the source. We are able to now take this data and we are able to consume this in multiple different systems. So let's say I want to consume this in a warehouse. I want to push this to Snowflake. I can do that. If I want to consume this in Salesforce, I can push this to Salesforce. If I want to consume this in a Databricks, I can do that as well. I can do a Delta on Databricks if I want to. So all of these connectors are already built in here, whether it is API, message buses, Kafka, API, etc. So I'll just take Snowflake as an example, quickly do this in a demo environment. And I come in here, let's say there's create a new table, so next, and I say I want to upsert this data, and this is my people demo table. And obviously we allow you how do you partition data, how do you cluster data, and all of that fun stuff. You want to, let's say email is my primary key here, and save. And this is essentially what it takes to build a data product driven data integration within Nexla, where you started from a source which was S3, you did some minor preparation, and then you're able to deliver this data. On top of this, the third layer, which is really, really important, is the layer of monitoring. So we give you ability to monitor. So ability to monitor is in multiple different places. So you can set your own uh, alerts. So you can say, I want to set alerts where the data is delayed. I want to set alert when record count is higher than what it was yesterday and all of that stuff. Or you can also get more fine-grained notification where data set is shared or when any errors happen. And these notifications then also be pushed to any systems of your choice. So you can push these data notifications into a webhook, into a Slack, or any other system that you would really want to push this in. So that's sort of a very high, quick overview of how we started the data product journey, how Nexla was able to do data products within the integration landscape. We talked about various different ways. I can take some questions here. We have about 4 minutes left for questions. I'll quickly go to my chat window and look at questions. And I can also invite you guys to the lounge. And if there's any specific questions that you would want to discuss, please come over at the lounge and would love to share more. So I'm going to quickly, oh, I see Saket has been answering some of these questions on the, uh, okay, so Gabriel has a question about the platform cannot really stop people creating multiple connectors for the same source and multiple derived data sets from one auto-generated one. Absolutely, you cannot stop, but the platform has intelligence to tell you that, hey, there is this duplication that you're potentially doing, and we can tell you that, hey, you already have a net set which goes to that particular place. So because it's all happening in this particular platform, uh, we are able to sort of detect those things while they are happening. Uh, there's one more question. Does the lineage feature span across different layers of data state? Will user get a lineage across multiple platforms? The lineage is limited to what is running within the Nextla landscape. Uh, and since we'll have full lineage of what is running within Nextla, but if let's say you are running a part of flow outside Nextla, at that point you would probably not have data lineage out there. Okay? And then I think Saket already answered the question. And very quickly, I'm trying to search if there is any other questions here. I have, if there is any other question, we have 2 minutes left, and I can try answering some questions here. Okay. Sounds good. Thanks, everyone. I hope to see you guys on the booth. Thanks for joining, and it was great sharing data products, data fabric, data integration landscape with all of you. Thank you very much.